So welcome to our maths projectiles exam question 3. Here we're doing projectiles with vectors and coordinates combined. So a player launches their aircraft from the origin with velocity 3I plus 18.7 j meters per second. At the same instant, the opponent launches the missile with minus 5I plus 18.7 j meters per second from coordinates 24, 0, where the coordinates are expressed in meters. The flight paths of both the aircraft and the missile occur in the same vertical plane, and I and j are respectively the unit vectors in both positive, horizontal, and vertical directions. Modeling the motion of both the model aircraft and the model missile as projectiles moving under gravity alone. Find the coordinates at which the missile hits the aircraft and how long both had been airborne prior to colliding. There are no I and j are vectors in the horizontal and vertical directions, so we can represent them as CVAT variables in the initial velocity as initial velocity vectors. So let's say that since the initial velocity is 3t here, you can say, and it's projected from 3t coordinate. This is the initial position. And for the other part, you know the question that minus 5i is here and 24 is here. So let's add up those coordinate vectors of minus 5 and 24. And let's represent, since s equals ut plus half at squared, here a equals 0. This is because as horizontal vectors we assume it's going horizontally, and we assume that there's no gravity acting on since it's not going up, and gravity is usually modeled as a downward vector. So this means, therefore, let's say s, let's take it as x1 and this as x0. And we say that since we have the 24 coordinate and minus 5, we say we can put minus 5t here because we substitute in this equation. And we can also add 24 since that's the other coordinate we have. other x value you have. Now we can equal them to each other. So this is because we know that the flight paths of both the aircraft and the vehicle and the flight path of the aircraft and the missile occur in the same vertical plane. So that means we can equal them. So 3t equals 24 minus 5t. Add 5t, 8t equals 24. T equals 3. And also seconds. And also let's take, if we substitute 3 in both equations, it will give us the coordinate in meters. This is because S equals UT for this equation, and if we substitute both, we can get the coordinate. So one of the coordinates are known. Now for the vertical direction, let's take that into consideration. Using S equals UT plus half T squared, S equals three T plus half minus 9.8 3 squared. Sorry, actually 18.7. Discard that because that is what we have here. We're using the vertical component because we need to find out the y coordinate. And in finding out the value to equate this equation, S would equal to we need to put 3 because we got the value for the time. S equals actually minus 8. Let's say minus 9.8. So because we take upwards as positive and this is the downwards, gravity is represented as a downwards, as a force, the downwards direction. And S would equal 12. So coordinates are 9, 12. And since the time is 3, it takes 3, can say that the prior to colliding missile and the aircraft airborne for 3 seconds before both collided at the coordinates 9, 12. And that's it. This has been Hamas. Thank you for watching. And it's really important that you note down these details, like gravity is represented as a force in down direction, and always when you're dealing with horizontal, you have to realise that A is always 0. Okay, thank you for watching.